Let's start a look at the orbit of Venus on the basis of some observations from a couple of weeks ago. Well, we see here 26th of March, crescent moon, and a considerable distance away we have the planet Venus. So the moon and Venus taken in the evening sky. Now the next night you can see the moon has actually moved closer to Venus, and the night after that the moon seems to have gone past Venus. So, moon moving with respect to Venus. Well, let's take a closer look at the circumstances here. So over those 3 nights we can see that the moon moved from here to about here to about here. Or we could say, yes, here to here to here. The moon moves along this kind of a path and passes Venus. Of course, a month later the moon will come back to this part of the sky, and so on. But what we do notice is the moon did not pass in front of Venus. It passed to the south of Venus, considerably to the south of Venus. There might be times that the moon moves to the north of Venus, or very occasionally will actually occult Venus. But on this particular occasion, yes, the moon had moved to the south of Venus. Now you'll see 27th of March the moon was some distance short of its closest pass to Venus. 28th it was that little bit past its closest pass. And of course this was the view from this part of the world, but as we move a little bit further east to the city of Ulyanovsk in Russia. This city actually lies on the river Volga, and at latitude 54 degrees is almost exactly due east of Sheffield. It's probably closer to being due east of somewhere in Teesside, for example. But it's a sizable city on effectively the same latitude as Sheffield, but a bit further east. So why do we go there? Well, let's have a look at a picture of the moon and Venus as seen from Ulyanovsk. And of course we see that we probably have here the moon at about its closest pass to Venus, but there's still considerable distance between the moon and Venus here. Well, let's just look in a little bit more detail with the lines of right ascension and declination marked here. So we actually have here the celestial equator 10, 20, 30 degrees north and so on, lines of constant declination, and we have lines of constant right ascension, the cosmic equivalent of longitude. But let's also draw in the ecliptic. The ecliptic is the path that the sun takes through the sky each year, and we can actually see Venus is 3.3 degrees north of the ecliptic, the moon 3.6 degrees south of the ecliptic. So we can see, well, actually Venus has passed almost 7 degrees to the north of the moon. And of course it's not just this month. Let's go back to the 27th of February. Here we see the moon and Venus. Again, Venus is considerably to the north of the moon. Of course, it's not as if Venus is stationary and the Moon is going past Venus. If we have a look at Venus itself moving in the sky with respect to the Pleiades cluster, we can see that over the course of, well, 4 out of 7 nights, Venus has moved from here, then up to here, then a little bit further away from the Pleiades star cluster, further away still. This picture's taken on a slightly different scale in order to let them both be viewed together, but Venus is itself moving. The Moon is moving considerably faster in terms of its angular motion in our sky, but Venus too is moving. Well, let's take a look at the orbits of the Earth and Venus. Here we see Venus and the Earth, Venus in brown, the Earth in blue, moving around the Sun. Well, we can see a few things. Venus moves more quickly around the Sun. It takes less time to go around the Sun. The Earth is on a slightly different orbit, but the interesting thing is that while Venus will never go around the back of the Earth, it goes between the Earth and the Sun, then it goes to the far side, and then back between the Earth and the Sun. Viewed from the Earth, Venus will alternately be on one side, behind the Sun, now on the other side, and then in front of the Sun. And that pattern will continue. So that's Venus and the Earth in orbit around the Sun. Now, making it stationary, looking at the orbits of the Earth and Venus, I have represented them by circles. It's true they're not quite circles. There is this figure, the eccentricity, which says how much the orbit differs from being a circle. For Venus, 0.007, less than 1%. The Earth is just a bit under 2%. Venus is the planet with the most circular orbit. The Earth is the planet with the third most circular orbit. Neptune has the second most circular orbit. So they really don't differ from circles much, so we're perfectly entitled to draw them as such. But, well, there's always a but. What's the but? It turns out that, well, the orbits are actually tilted. They can be at an angle of about 3.4 degrees. There is a difference in the orientation of the two orbits. Here we see Venus and the Earth in orbit around the Sun. But let's look at things from different angles. We can look from virtually above the whole system, and then, yes, very much as we saw in the previous two-dimensional look, we have the Earth and Venus orbiting around the Sun. It is Venus that orbits faster. It's moving faster, it's on a smaller orbit, so it makes an orbit in less time. But let's tilt things so that now we can see that there is a slight tilt between the orbits of Venus and the Earth. So Venus on a slightly smaller orbit, the Earth on a larger orbit, but we can indeed see there is this tilt between the two orbits. So it would seem that sometimes, because of this tilt, Venus could appear to the north of the Sun, or Venus could appear to the south of the Sun. North or south of the ecliptic. So an interesting question, just how far north, or indeed south, of the ecliptic can Venus get? Well, let's look at the circumstances under which Venus would appear furthest north or south. It would be passing the Earth in its orbit. So here we see Venus at its extreme part of its orbit towards the Earth, but tilted up by 3.4 degrees. We do a bit of trig, and we find that Venus can actually get to 8, almost 9 degrees north or south of the ecliptic. So Venus, well, it was around 4 degrees north of the ecliptic recently, but it can get more than 8, almost 9. For example, one occasion, well, looks like we're heading for a contradiction. What do I mean by that? But one occasion where Venus gets more than the current 3 or 4 degrees north of the ecliptic will be in just under 2 years from now, 27th January 2022. And here we see in the morning sky, you can see it's just before 7 in the morning in January. The sun's down here somewhere. It's about to rise and make everything harder to see. But we can see, well, firstly, we can see Mars is fractionally south of the ecliptic, as is the Moon. But Venus is actually almost 7 degrees north of the ecliptic here. But if you recognize, we have Altair here, we have Antares here, Scorpio, Sagittarius here. This is in the extreme southern part of the sky. Here is the celestial equator, but here is the ecliptic. So Venus considerably north of the ecliptic here, but in the southern part of the sky. Well, actually that raises a question. If Venus can be 8 degrees north of the ecliptic, does that mean it can get up to 32 degrees declination and be visible from the north of Scotland? Well, no. It won't happen, not in the current epoch. It can appear 8 degrees north of the ecliptic in constellations such as Scorpio and Sagittarius, but those are in the extreme southern part of the sky. We will need to wait another 10,000 years or so for the orientation of the pole star and so on to change round, so that Scorpio and Sagittarius are as far north as Gemini and Taurus are now. And when that happens, yes, we will have occasions when Venus can be circumpolar from the north coast of Scotland.